Assalamualaikum warahmatullahi wabarakatuh. My name is Cik Umi Tafira binti Cik Zulkarnain. So this is my video presentation on analysis of 3D print based structural joint in UAV. This presentation consists of 6 elements, which is introduction, problem statement, objective, literature review, methodology, and expected result. In this introduction section, I will briefly explain you what is UAV and the scope for this project. So UAV, Unmanned Aerial Vehicle, is a remotely piloted aerial system, RPAS, which needs an operator to operate the system from the ground. According to Eric Muller and Matt Jardine, the UAV must provide the level to detect, see and avoid capability equivalent to manned aircraft through radar observation, camera, electronic detection system or some other method. So example of UAV could be drones or RCM plane. The UAV which widely used nowadays has the function for remote sensing, transport, search and rescue, armed attack, and also for research. The UAV has two types of wings, which are rotary wings and fixed wing. For rotary wings powered by rotary blade, such as helicopter, and for fixed wing means that the wings do not move. The fixed wings consist of 5 main components, which are fuselage, wing stabilizer, landing gear, and also flight control. This project will be focused on fixed wing aircraft and the wings component itself. There are also two types of joints that will be discussed throughout this presentation, which are lug joint and also lap joint. Lug joint may be used to connect two different wing boards through connection of male and female lug. Meanwhile, the lap joint, which also known as double joint, used to connect the wing boards by overlap a plate on wing surface by bonding it with screws. Therefore, this project is carried out to compare the strength and to find out suitability of lug joint and double joint on aircraft wing of 3D prints. Now we move to problem statement. The 3D printing will use polylactic acid (PLA) as the filament. The joints such as lug joint and double joint are made of polylactic acid (PLA) tends to meet failure if not go through proper design analysis. In addition, this project reference will be BWB-9 aircraft, the first 3D aircraft made by FTTC UiTM. The current joining method used is a permanent joint. They used a Gorilla Glue to connect the wing boards. So this type of permanent joint make the wing boards cannot be disassembled when needed. In order to solve the problem mentioned in the previous slide, so the objective of this project are as follows. First, to design and manufacture lug and double wing joints based on PLA 3D printing manufacturing. The second one, to determine the stress and deformation of the lug and double wing joints by FE simulation. And the third one, to determine the strength of the lug and double joints designed by static experiment. Next, we move to literature review. So literature review is important in this project to gather related information from published research paper. The scope for the literature are 3D print aircraft, information on polylactic acid, the component of fixed wing aircraft, and also analysis on lug and double joint. So the first literature is by John Mark Muschetta and Kamesh Namuduri, which state the UAV is a remotely piloted aerial system which widely used in aeronautic for aircraft modeling. The second one, by Max Paul, state that the aircraft model can be built by 3D print. This use laser-assisted machines to create structure of plastic such as polylactic. fatty acid (PLA), building up the element layer by layer. The aircraft had no undercarriage to keep complexity and reduce weight. Previous statement is supported by similar research by Igor Skowronski and Thomas Gordonsfors-Grabowski. Their research found that PLA print results in highest quality of the surface, the thickness of the wall is smooth, the structure is water resistant, ensuring that there are no holes in the thin wall. Inside the frame, no air blocks are visible and there are no print inconsistencies in area where the material is retracted. PLA also provides strong mechanical properties as well as layer addition. So the fourth literature is by M. Sadre, emphasized in his book that fixed wing aircraft model consists of 5 important parts, which are fuselage, wing, horizontal tail, vertical tail, and control surface. The fifth literature is by K. Shrida, B. S. Suresh, M. Mohan Kumar, and also by Tomohiro Taichi et al. Both research are focusing on fatigue analysis of lug joint and lap joint in aircraft structure respectively. The fatigue analysis of lug joint shows that maximum stress concentration occurs at a location approximately perpendicular to the loading direction. And the last one, the literature is by Abrugani AF and Ahmad Rifai. They say the single lap joint may experience crack due to peel and shear stress. For methodology, we may refer the flowchart shown in the slide. So the flowchart of methodology for this overall project is constructed. The flowchart covers overall research, the preliminary study of BWB-9 aircraft, design process, FE simulation, 3D print, static experiment, and also thesis writing. As we go through the details of the methodology, so the first one, to study the process, research and development of BWB-9 aircraft. As I mentioned before, it is the first 3D printed aircraft by Flight Technology and Test Center UiTM. The second one, identify the BWB-9 structural joint weakness and make it as the study's problem statement. Collect information from published research paper. The wing box joining method of this first 3D printed aircraft is a permanent joint. They use Gorilla Glue to connect the wing box, which cannot be disassembled when needed. So the third one, determine the dimension and specification of BWB-9 aircraft using OpenVSP software. The dimensions are as shown in the slide. So let's talk about spar and rib thickness value. So the spar thickness could be 1 mm only. However, local region where the joint happen will be high concentrated load. So it is safer to make it a slightly thicker up to 2 mm to avoid tear out. For rib, it can be as thin as possible. So 0.8 mm is the minimum thickness, but no more than 1.5 mm. So the rib thickness is set to 1.5 mm considering the maximum thickness of the rib. The next one, develop CAD drawing of wing box and joints using CATIA. The drawing also consider the standard part dimension, which is nylon screw with 5 mm dimension. Nylon screw is fasteners used by FTTC UiTM. It resistant to corrosion, less in weight, and offer high resistance to wear. If we look at the lug joint drawing shown in the slide, the wing box has a rib and spar. There are two types of lug, horizontal lug and vertical lug. These two types of lug will withstand difference of force. Horizontal lug dealing with drag force, meanwhile vertical lug dealing with lift force. The lug thickness, which is set to 3 mm, thicker than spartiness, which is only 2 mm. It is important for the lug thickness to thicker than spartiness to withstand the load, and to prevent failure. So this is the double joint drawing, and we could see there is also drip and spar, same as the lug joint drawing shown before. The drip is 1.5 mm and the spar thickness is 2 mm. There are also built-in nut. So the nut is mounted to the wall inside of the wing box because of the limited space need to tighten the screw later on. Perform finite element method by CATIA software to determine maximum stress level and load magnitude of both joints. So from the FE analysis conducted, the lug joint is expected to withstand a maximum stress of 0.215 megapascal, and the double joint is expected to withstand 0.325 megapascal. So the both value is not exceed the yield strength of a plastic, which is 26.082 megapascal. The sixth one is the drawing is then being proceed to 3D print. The honeycomb infill with the range of 2% to 5% is used for better reinforcement of the wing structure. If we look at the table shown, the recorded printing data from FTTC shows that the infill and the weight of the printed wing box. Even though the infill is small in percentage, but the weight is quite heavy. Hence, it's only sufficient for us to use 2% to 5% infill. The next one, printed wing box are assembled by M5 nylon screw. The strength of the joint is tested. The strength of the joint is tested by static experiment, which one end of the wing board is connected to the jig or support as if it is connected to the fuselage. The load is applied to the surface of the wing box till the joint breaks. Then the amount of load is being recorded. The last one, do calculation to determine stress level and load to the joints can withstand experimentally. The calculation is done after perform static experiment using the data obtained, which is the amount of the load recorded till the joint break. Theoretically, the joint should carry about 100 Newton load, and the calculation is as shown in the slide. Moving forward to expected result. Expected result is how the objectives are achieved by the end of the project. So the objective 1, to design and manufacture lug and double wing joint based on PLA 3D printing manufacturing. Expected printed product for this joint are as in figure shown in the slide. This is the bigger view of the drawing. The lug joint will connected by nylon screw, same as the double joint, and the double joint is located at the both sides of the wing box. Objective 2, to determine the stress and deformation of the lug and double wing joint by FE simulation. As I mentioned before, from the FE analysis conducted, the lug and double joint are expected to withstand maximum stress of range 0.215 megapascal and 0.325 megapascal respectively. The joint should carry about 100 Newton per wing. The maximum stress is not exceeding yield 26.082 megapascal for plastic material. If we look at closer to the diagram shown, we could observe there is more stress occur at the joining section for both type of joint. For the last objective, to determine the strength of the lug and double joint designed by static experiment. The static experiment enables us to observe the failure mechanism of the joint, such as screw thread stripping, tear out of the lug, bearing stress, and tensile failures of the doubler. That's all for my presentation. For Q&A session, you may reach me at the contact info shown at the slide, or you may also scan the QR code prepared, and I will gladly to answer the question. Thank you for watching.